Hello and welcome to TalentSprint. In this session of geography, we shall discuss the part 7, which is related to atmosphere. So generally we have 8 planets from Mercury to Neptune, right? So out of these 8 planets, only atmosphere exists for the Earth. Atmosphere exists for other planets also, but it is not sustaining life. There are not variety of gases in other planets, but there are variety of gases in the Earth's atmosphere. So we shall discuss more about Earth's atmosphere in this topic. What are the layers of atmosphere? What are the different chemical compositions? What are the different specifications of different layers? Okay, are you ready? Shall we start? Yes. So moving on to atmosphere. What is an atmosphere? Atmosphere is nothing but it is a blanket of gases. It is nothing but it is a blanket of gases which is covering our Earth. Without atmosphere, there is no life on Earth. Okay, we need hydrosphere, lithosphere, that is crust, Earth's crust, and then atmosphere. Then only biosphere is possible. Okay, so highest component of this, all these gases in the atmosphere is for nitrogen. How much percentage? 78.08. So 78 percentage is of nitrogen. And next comes oxygens with 20.9 percentage. That is 21 percentage is oxygen. Then only 1 percentage is left. Generally the questions will come saying which is the third highest component in the atmosphere. So generally we think that carbon dioxide, but it is not. The third highest component is argon with 0.93 percentage in the Earth's atmosphere, which is an inert gas. Then comes we have carbon dioxide 0.036. Then comes other gases. So first is nitrogen 78%, then is oxygen 21%, then argon 0.93%, and then comes carbon dioxide with 0.036%, and then others. Okay, remember this. Moving on, the other components of atmosphere is we have dust particles, water vapor, there is moisture in the air. We have also have these dust particles, that is, and moisture, that is water vapor in the air. Okay, moving on to layers of atmosphere. What are the different layers? We have 5 layers generally. So based upon the density, they are arranged. Higher the density of that layer, it will settle down. Lesser denser, it will be higher. It will be at the higher heights. So we have 5 layers starting from the Earth. From the down, we have Troposphere, then Stratosphere, then Mesosphere, then Thermosphere or Ionosphere, then Exosphere. Okay, so from the layer which touches the Earth is Troposphere. Okay, remember this. Moving on to the layers. The first is Troposphere, which touches the Earth's surface, and it is thinner at the poles and thicker at the equator. It is at around 8 kilometers thickness at the poles, that is North Pole and South Pole, and at the equator it is 18 kilometers, because at the equator there is higher temperature, right? Because Earth shape is like almost a sphere, right? That is geoid shape. So equator will receive more heat. That's why the heated air will rise up. So at the equator, the thickness of troposphere is high, that is around 18 kilometers, and at the poles it is only 8 kilometers. And after the troposphere, we have stratosphere. So the juncture of troposphere and stratosphere is tropopause. So we can say whenever there is tropopause, that is the ending of the troposphere. Clear? And the features of troposphere is, as we move towards from the Earth, away from the Earth, the temperature will fall down. Obviously it will fall down. Temperature and pressure will fall down when we move away from the Earth, from the Earth's surface. Okay, and all the weather phenomenon, including rainfall, snowfall, fog, hail, all these will occur in troposphere only. Remember this very repeated question and star mark question, very important. All the weather phenomenon, including rainfall, cloud formation, fog, hail, snowfall, all these will happen only in troposphere. Okay, remember this. The next layer is, after troposphere we have stratosphere, away from the Earth. So it extends up to the height of 50 kilometers from the surface of the Earth. Okay, and the temperature in the air in this layer will be first constant, then it will slowly increase, okay, up to 50 kilometers altitude. Then ozone layer is present in the lower layer of stratosphere. What is the use of ozone layer? Ozone layer is the one which protects us from the harmful UV radiation which is coming from the sun. Okay, nowadays we are damaging this ozone layer because of the uh, chlorofluorocarbons, greenhouse gases. All these are damaging the ozone layer. So we must protect our ozone layer which is present in the stratosphere. Okay, this is a very repeated question. Ozone layer is present in the stratosphere. And next important point is stratosphere is always free from clouds. Already the cloud formation is in troposphere. There will be no clouds in the stratosphere. So that's why it is very ideal for flying of aeroplanes or rockets or anything. Not rockets, only aeroplanes and any other jets. Okay, which can fly in the stratosphere without any clouds. Clear with this? So aeroplanes will fly in the stratosphere because of less cloud formation, because already clouds are getting formed in the troposphere. Okay, next is after the stratosphere we have stratopause, ending of stratosphere, then we have mesosphere. So mesosphere is the third layer of the atmosphere after the troposphere and stratosphere, and it extends up to a height of 80 kilometers from the surface of the earth. And generally the meteors, I've already discussed, meteors, the shooting stars, enter the earth's atmosphere and that get burned up because of the friction between the dust particles and the meteor, right? So they enter the earth's atmosphere and they get burned up in the mesosphere. Remember this, the meteors will get burned up in the mesosphere. Okay, so after mesosphere, at the end of the mesosphere we have mesopause, and then we have the thermosphere or ionosphere. Okay, so in the thermosphere the temperature rises rapidly. Okay, the mesosphere it falls. Alternatively, it will increase first in troposphere, it will decrease. In stratosphere it will increase. In mesosphere again it will decrease, and in thermosphere it will increase. There will be alternatively increase and decrease of temperature in the different layers. Okay, and it contains electrically charged articles or particles. Those are called ions. That's why it is called as ionosphere, and it will extend up to a distance of 80 to 400 kilometers. Okay, clear about thermosphere? And this thermosphere is used for radio transmission. Okay, whenever we send radio waves from the surface of the earth, they are reflected back by the thermosphere or ionosphere. Remember this. Okay, if they are not reflected back, we cannot receive the radio waves. So when we send the radio waves from the earth's surface and they are reflected back to the earth by the thermosphere or ionosphere. Okay, and International Space Station and satellites orbit in this layer, and auroras, I've already told you, northern lights are called aurora borealis and southern lights are called aurora australis. So auroras are generally observed in lower parts of the thermosphere. The northern lights are called as aurora borealis and the southern lights are called as aurora australis. Okay, moving on to next layer of the atmosphere, that is exosphere. So exosphere is the topmost layer of the atmosphere and generally touches the space, and very less pressure and temperature exists there. Almost you can say it's a space only, it touches with the space. After it exists after 400 kilometers. Okay, and the temperature and pressure are very high, and generally it has gases of helium and hydrogen. Most of the planets we have helium and hydrogen only. So in the space also we have helium and hydrogen, and temperature gradually increases and the layer coincides with the space. So this is about all the 5 layers: troposphere, stratosphere, mesosphere and thermosphere, that is ionosphere, and exosphere. We can see on screen where the weather phenomena occurs, troposphere; where the aeroplanes fly, stratosphere; where the ozone layer occurs, stratosphere. Okay, and where the meteors get burned up, in mesosphere; where the radio waves are reflected back, that is thermosphere or ionosphere. Okay, hope you remember these important points. And coming to greenhouse effect, so sometimes we get the questions from greenhouse gases. So I want to discuss this in this topic, greenhouse effect. What is greenhouse effect? Generally, in colder regions, it is very difficult to get the sun's rays. So generally what they do is they will form a small greenhouses where the sun's heat, smaller amount of sun's heat will be trapped inside the greenhouse, and it will be used to provide the sunlight for those plants in that greenhouse, so that the temperature will not fall. That is called greenhouse actually. So here this greenhouse effect means whenever we receive the sun's radiation, okay, it should be totally reflected back to the atmosphere. But what happens is some part of the sun's radiation will be trapped by some gases. So those gases will heat up the earth's surface more. If there are no greenhouse gases, earth's temperature would have been around 15 degrees centigrade, or it would be been in the minus centigrades. Okay, if there are no greenhouse gases. But what happened is nowadays the greenhouse gas production is high, and the more amount of heat is trapped from the sun's radiation, and they are heating more, and we are getting higher temperatures. We can see in summers how the temperatures are. Now the deserts and the normal land temperatures are almost equal in summers, right? And in winters they are very cold. Okay, this variation should not be high between summer and winter temperatures. Okay, but this is happening because of the heating up of the greenhouse gases, which are absorbing the sun's radiation and making the earth's surface heated up. So what are the greenhouse gases generally present? So naturally we have the highest greenhouse gas is the water vapor. Water vapor contributes a lot to the greenhouse gas effect. It will absorb a lot of heat from the sun's radiation, which is reflected back from the earth. Okay, that is natural. We can't control water vapor, right? So water vapor, carbon dioxide and others, that is natural. Then what about man-made or artificial? So the highest contribution is carbon dioxide, which is released from vehicles, thermal power plants, industries, all these, right? And next comes methane, and next comes nitrous oxide, N2O, and next comes fluorinated gases from refrigerators, air conditioners, chlorofluorocarbons. So first highest is carbon dioxide, then methane, then nitrous oxide, N2O, and fluorinated gases, chlorofluorocarbons. All these are contributing towards the greenhouse gas effect, and they are making the earth heated up. Okay, so we must contribute for the lesser global warming, right? We should emit less greenhouse gases so that they will not warm up the earth's surface. So hope you have learned enough topics in the atmosphere. We shall meet in the next sessions. Thank you so much.